The time to work on your lab. Okay, so last week we talked about exothermic and endothermic reactions. Guys, adults talking. Hey. So last time we talked about endothermic and exothermic reactions, and we learned that an exothermic reaction is one where energy is released, and an endothermic reaction is one where energy is absorbed to keep the reaction going. Well, you can add energy to a product as a product when it's an exothermic system, and you can add energy as a reactant when it's an endothermic system. So this is the combustion of methane, good old-fashioned methane gas. And the way you would read this is if 1 mole of methane was burned in 2 moles of oxygen, not only would you make the 2 moles of water and the 1 mole of carbon dioxide, you would release 888 kilojoules of energy. And that's the unit we use. It's kJ, which is kilojoules. The standard unit of energy in science is the joule. So for every 1 mole of methane you burn, you're going to produce 888 kilojoules of energy. Similarly, for every 2 moles of water you want to decompose, this is the decomposition of water, for every 2 moles of water you want to decompose, you're going to need 571 kilojoules of energy. So when we have an endothermic system, energy acts like a reactant. In an exothermic system, energy acts like a product. And it can be mathematically manipulated. So if I said, how much energy would I produce if I burned 2 moles of methane, I would simply double my 888. And if I wanted to know how much energy would I need to only decompose 1 mole of water, I would just take this number and divide by 2. Make sense? Okay, so if we get to thermochemistry at the end of the year, and I really hope we do, then we'll actually spend a little more time on this idea. But for now, just realize that in an endothermic system, energy acts like a reactant. And in an exothermic system, energy acts like a product. Okay. Any questions? Then we move on. That's right, product. Okay. In single replacement reactions, we have one element all by itself, and it goes in and it kicks another element out of a compound. Now, not all elements have the same ability to kick out other elements. They are more active. Some are more active than others. And we have the activity series, which is a list, not a complete list, but it's a pretty good list of metals and how active they are. For instance, lithium is the most active metal we have. If lithium is as an atom, it can kick out any other metal in a compound. Lithium would rather be in a compound than by itself. On the other hand, gold is the least active metal. Gold can't be kicked out by, or can be kicked out by everything. Gold would rather be as an element rather than a compound. So if iron's cruising along and iron finds tin in a compound, iron will kick out tin, tin will come out, iron will go in. Lithium can kick out everything. Gold can't kick out anything. This is a large part of the reason we can find veins of gold and silver in rocks. They would rather be elements than be compounds. You can't find elemental lithium anywhere. It's always in a compound form. Okay, so this is the activity series. I'm not going to, hey you, bring back my gold watch. I'm not going to ask you to memorize the activity series or anything crazy like that. I just want you to know that how it works. You just need to be able to use it. And how it works is anything that is more active can kick out something that is less active. Anything above can kick out anything below. That's how we use the activity series. Okay, questions about this? Then to practice we go. Okay. Oh, sorry, before we do practice, there is one type of reaction that you should know about. It's a special type of reaction, and it occurs when the oxidation of elements in compounds or outside compounds change. It's called a redox. Stands for reduction oxidation. I also like to think of it as redoing oxidation. So you are redoing the oxidation of elements. So your favorite element, or your favorite reaction, this is thermite, the powdered thermite. When we did thermite, we put powdered aluminum and powdered iron oxide together, and it gave off a whole bunch of heat, and it released aluminum oxide into the air as smoke, and left behind molten iron. And we picked it up with a magnet. Okay? So this is a redox reaction where the oxidations actually change. What is the oxidation of any free element? 0. So the oxidation of this aluminum would be what? 0. So the oxidation of that aluminum is 0. The oxidation of that iron is +3, and the oxidation of oxygen is -2. So iron starts +3 and eventually becomes what? 0. Aluminum starts 0 and eventually becomes +3. Okay? So this is a redox reaction. Aluminum starts as 0, becomes +3. Iron starts as +3 and becomes 0. We have special names for each type of change. When the oxidation goes up, we call it just oxidation. It's just oxidation. The reason we talk about the oxidation of compounds, like the oxidation of metal or the oxidation of iron, oxidation of copper, that's because you have elemental iron and it rusts. It goes from 0 to +3. That's oxidation. The opposite of oxidation is reduction. In this case, the iron is reduced. The iron is reduced from a +3 to a 0. And you can't have one without the other. So oxidation is what happens when the oxidation number increases. Reduction is what we call it when the oxidation number decreases. If we get to electrochem in the spring, then we'll use oxidation reduction reactions a lot. At this point, just know what they are. Like, oh, that's when the oxidation number changes. If it goes up, it's oxidation. If it goes down, reduction. I'm actually going to use your ID cards that we made at the beginning of the year. Physics uses them all the time. We should use them more in chemistry because I keep getting the same 4 people answering questions. So we're going to practice if there's no questions. Are there any questions about redox reactions? Okay, cool. So for the next, I don't know, 15, 20 minutes, we're just going to practice balancing. Here are 6 reactions. And what we're going to do is I'm going to give you time to balance them, and then I'm going to randomly call on 6 people from their cards, and you're going to put your work on the board. So take some time, balance these guys. And we have one more concept to talk about after we balance these. Yeah? Yes. Yeah, it can. It's pretty rare, but yeah, it happens, and I'm probably going to shield you from it in this class.